Welcome to my class of cloud computing. Today we will learn about parallel and distributed programming paradigms, MapReduce. Before going into the working of MapReduce, let us first understand the working of distributed and parallel computing system. While both distributed and parallel systems are widely available these days, the main difference between the two is that a parallel computing system consists of multiple processors that communicate with each other using a shared memory, whereas in distributed computing system contains multiple processors connected by a communication network. In parallel computing system, as the number of processors increases with enough parallelism available in application, such systems easily beat sequential systems in performance through the shared memory. In such system, the processor can also contain their own locally allocated memory, which is not available to any other processors. In distributed computing system, multiple processor systems can communicate with each other using messages. They are sent over the network. Such systems are increasingly available these days because of the availability of low price of computer processors and the high bandwidth links to connect them. These are the features or the working principles of distributed and parallel computing systems. While both distributed computing and parallel systems are widely available these days, the main difference between these two is that a parallel computing system consists of multiple processors that communicate with each other using a shared memory, whereas a distributed computing system contains multiple processors connected by a communication network. There are several reasons why a system should be built distributed, not just parallel. Scalability is one of the reasons, as distributed systems don't have the problems associated with shared memory. With the increased number of processors, they are regarded as more scalable than parallel systems. Reliability. The impact of the failure of any single subsystem or a computer on the network of computers defines the reliability of such a connected system. Definitely, distributed systems demonstrate a better aspect in this area compared to parallel systems. Data sharing. Data sharing provided by distributed system is similar to the data sharing provided by distributed databases. The multiple organizations can have distributed system with the integrated applications for data exchange. Resource sharing. If there exists an expensive and a special purpose resource or a processor which cannot be dedicated to each processor in the system, such a resource can be easily shared across distributed system. Heterogeneity and modularity. A system should be flexible enough to accept a new heterogeneous processor to be added into it and one of the processors to be replaced or removed from the system without affecting the overall system processing capability. Distributed systems are, or the distributed systems can be described with, or they are observed to be more flexible in this respect. The geographic placement of different subsystems of an application may be inherently placed as distributed. Local processing may be forced by the low communication bandwidth, more specifically within the wireless network. Economic. With the evolution of modern computers, high bandwidth networks and workstation are economic to work with. So there is an economy in when there is low cost, which also favors distributed computing for economic reasons. Parallel versus distributed systems. These are the difference between parallel versus distributed systems. As when we compare memory, parallel systems are tightly coupled shared memory, UMA, NUMA, etc. Distributed memory, message passing, RPC and or use of distributed shared memory. Control, global clock control, SIMD, MIMD. In distributed system, no global clock control, synchronization algorithms needed. Processor interaction, order of TVPS, bus, mesh, tree, mesh of tree and hypercube network. Order of GBPS, Ethernet, token ring and SCI. Main focus is the focus of parallel system is on scientific computing, whereas in distributed systems the main focus is on performance, cost and scalability, reliability, availability, information and resource sharing. In parallel computing, types of computation in which many calculation or the execution of processes are carried out simultaneously. A system whose components are located on different network computer which communicate and coordinate their action by passing messages to one another occurs in a single computer involves whereas distributed computing involves multiple computers. In parallel computing, multiple processors execute multiple tasks at the same time, whereas in distributed computing, multiple computers perform tasks at the same time. Computers can have shared memory or distributed memory in case of parallel computing. Each computer has its own memory in distributed computing. This is the diagrammatic representation of distributed computing and parallel computing. In case of parallel computing, there are several processors associated with a single memory, whereas in distributed computing there are different processors are allocated with different memory. So there is a distribution of work. The map-reduce programming paradigm. The map-reduce first of all, let us understand the concept of map-reduce. What is map-reduce and what are the features? The the key value pair is the record entity that MapReduce job receives by execution. MapReduce is a programming paradigm that was designed to allow parallel distributed processing of large set of data, converting them to set of tuples and then combining and reducing those tuples into smaller set of tuples. The MapReduce in MapReduce is used, or it is paired with Hadoop to get different types of data processing or large processing of data which are required in cloud computing. The key value pairs in Hadoop MapReduce is input split, record reader. Input split is the logical representation of data. The data to be processed by an individual mapper is presented by the input split, and in record reader it communicates with the input split. It converts the split into records which are useful for cloud computing paradigm concepts. Since cloud computing works with huge amount or voluminous amount of data, so the MapReduce paradigm is helpful when compared with Hadoop. So whenever, in layman's term, MapReduce was designed to take big data and use parallel distributed computing to turn big data into little or regular sized data. In MapReduce, map function processes a certain key value pair and emits a certain number of key value pairs, and reduce function processes values grouped by the same keys and emits another set of key values pair as output. Parallel distributed processing refers to a powerful framework where mass volumes of data are processed very quickly by distributing processing tasks across clusters of commodity servers. With respect to MapReduce, tuples refer to the key value pairs by which data is grouped, sorted and processed. MapReduce jobs work via map and reduce process operation sequence across a distributed set of servers. In the map task, we delegate the data to key value pairs, transform it and filter it. Then we assign the data to nodes for processing. In the reduce task, we aggregate that data down to smaller size data set. Data from the reduce step is transformed into a standard key value format where the key acts as a record identifier and the value is the value that is being identified by the key. The cluster's computing nodes processes the map and reduces tasks that are defined by the user. MapReduce is a processing technique and a program model for distributed computing. Actually, it is based on Java. MapReduce algorithms contains two important tasks, namely map and reduce. Map takes a set of data and converts it into another set of data, where individual elements are broken down into tuples, key pair values. Secondly, reduce task, which takes the output from a map, as an input and combines those data tuple into a smaller set of tuple. As the sequence of the name MapReduce implies, the reduce task is always performed after the map job. The major advantage of MapReduce is that it is easy to scale data processing over multiple computing nodes. Under the MapReduce model, the data processing primitives are called mappers and reducers. Decomposing a data processing application into mappers and reducers is sometimes non-trivial, but once we write an application in MapReduce form, scaling the application to run over hundreds, thousands, or even tens of thousands of machines in a cluster is merely a configuration change. The simple scalability is what has attracted many programmers to use the MapReduce model. MapReduce model is helpful in cloud computing. If this model is a specialization of the split apply combined strategy of data analysis. This is a combination of split and apply strategy. MapReduce allows distributed processing of the map and reduction operation. Map can be performed in parallel provided that each mapping operation is independent of the others. In practice, this is limited by the number of independent data sources or the number of CPUs near each source. Similarly, a set of reducers can perform the reduction phase provided that all outputs of map operation that share the same keys are presented to the same reducer at the same time, or that the reduction function is associative. While this process often appears inefficient compared to algorithms that are more sequential because multiple instances of the reduction process must be run, MapReduce can be applied to significantly larger data set that a single commodity server can handle. A large server firm can use MapReduce to sort a table of data in only a few bytes or few hours. The parallelism also offers some possibility of recovering from partial failure of servers or storage during the operation. If one mapper or reducer fails, the work can be rescheduled, assuming the input data are still available. The map reducing programming paradigm is inspired by map and reduce functions commonly used in functional programming, although this purpose in the map reduce framework is not the same as in their original forms. The key contributions of the map reduce frameworks are not the actual map and reduce function, which for example resemble the 1995 message passing interface standards reduce and scatter operation, but the scalability and fault tolerance achieved for a variety of applications by optimizing the execution engine. MapReduce framework. A MapReduce framework is usually composed of three functions. First, map. In this step, each worker node applies the map function to the local data and writes the output to a temporary storage. A master node ensures that only one copy of the redundant input data is processed. Shuffle. Worker nodes redistribute data based on the output keys such that all data belonging to one key is located on the same worker node. Third step is reduce. Worker nodes now processes each group of output data per key in parallel. MapReduce allows for the distributed processing of map and reduction operation. Maps can be performed in parallel provided that each mapping operation is independent of the other. In practice, this is limited by the number of independent data source or the number of CPUs near each source. Similarly, a set of reducers can perform the reduction phase provided that all outputs of the map operation that share the same keys are presented to the same reducer at the same time, or that the reduction function is associative. While this process often appears inefficient compared to algorithms that are more sequential because multiple instances of the reduction process must be run. MapReduce can be applied to significantly large data set that a single commodity server can handle. A large server farm can use MapReduce to store a petabyte of data in only a few hours. Another way to look at MapReduce is a 5-step parallel and distributed computation. First step is prepare the map input. The MapReduce system designates map processors, assigns the input key K1 that each processor would work on, and provides that processor with all the input data associated with that key. Second step is run the user provided map code. Map is run exactly once for each K1 key, generating output organized by key K2. Third step is shuffle the map output onto reduce processors. The MapReduce system designates reduce processors, assigns the K2 key for each processor should work on, and provides that processor with all the map generated data associated with the key. Run the user provided reduce code. Reduce is run exactly once for each K2 key produced by the map step. Produce the final output. The MapReduce system collects all the reduce output and sort it by K2 to produce the final outcome. These 5 steps can be logically thought of as running in sequence. Each step starts only after the previous step is complete, although in practice they can be interleaved as long as the final result is not affected. In many situations, the input data might have already been distributed among many different servers, in which case the prepare and map step could sometimes be greatly simplified by assigning map servers that would process the locally present input data. Similarly, the shuffle step could sometimes be sped up by assigning reduce processors that are as close as possible to map generated data they need to process. Usage of MapReduce in cloud computing. Hadoop provides a sophisticated framework for cloud platform programmers, which MapReduce is a programming model for large scale data set of parallel computing. By MapReduce distributed processing framework, we are not only capable of handling large scale data and can hide a lot of tedious details, scalability is also wonderful. The reducer classes is based on MapReduce framework that enables distributed programming, which is a feature of, or which is an integral feature of cloud computing. MapReduce or cloud computing is designed to provide on-demand resources or services over the internet, usually at the scale and with the reliability level of a data center. MapReducing is a programming tool designed for processing large volume of data in parallel by dividing the work into a set of independent tasks. It is a style of parallel programming that is supported by some capacity on demand style clouds such as Google's Bigtable, Hadoop and Sector. These are all clouds. MapReducing algorithm was implemented in a system using Hadoop, Eclipse on Ubuntu 8.2 or above. The cloud architecture has both master and slave nodes. So in the implementation, a main server is maintained that gets client request and handles them depending on the type of request. The master node is present in main server and slave node in secondary server. Search requests are forwarded to the name node of Hadoop present in main server. The Hadoop name node then takes care of searching and indexing operation by initiating a large number of map and reduce processes. Once the MapReduce operation for a particular search key is completed, the name node returns the output value to the server and in turn to the client. If the request is for particular software, authentication steps are done based on the customer tenant ID, payment dues, eligibility to use a particular software and the lease period of software. The server then serves this request and allow the user to consume a selected software combination. The multi-tenancy feature of SaaS, in which a single instance of the software serves a number of tenants. For every tenant specific request, there will be a thin line of isolation generated based on the request. MapReduce programs are designed to compute large volumes of data in a parallel fashion. This requires dividing the workload across a large number of machines. Hadoop provides a systematic way to implement the programming paradigm. The computation takes a set of input value pairs and produces a set of output key or value pairs. The computations, as already explained, it is divided in two-step map and reduce operation. The map function emits each word plus an associated count of occurrence, and the reduce function sums together all count emitted for a particular word. Performing computations on large volume of data has been done before, usually in a distributed setting. What makes Hadoop unique is its simplified programming model, which allows the user to quickly write and test distributed systems, and its efficient automatic distribution of data and work across machines, and in turn utilizing the underlying parallelism of CPU cores. Nodes in the cluster have preloaded local input file. When the MapReduce process starts, the name node uses the job tracker process to assign tasks which have to be carried out by data node through the task tracker process. Several map processes will run in each data node, and the intermediate result will be given to the combiner process, which generates, for instance, the count of word in a file of one machine. Values are shuffled and sent to reduce process, which generate the final output for the problem of interest. Thank you.